Hello, in this video I'm going to go over creating characters for the Game Boy Color and choosing color palettes for your characters. So to start off with, you'll see here that I have 2 frames of animation for my fish character drawn specifically for the Game Boy Color. So at the top here you'll see that there are the 4 colours for this character. So all of these colours should be divisible by 8 to match the Game Boy Color's colour scheme. I'll just change that a minute. So the colours which I've chosen are arranged in such a way that they should work fine on the standard Game Boy if the program was to be run on there. So the colour palette goes from light to dark. So when you're drawing your characters, it's probably best to keep the top line set aside for your colour palettes. This makes it easy to keep track of what colours you use, and it is also needed in my graphics converter program as well, which will then allow you to convert the images into data and also palettes for use in your own program later on. So these characters are made or will be built of tiles. So just change some settings here for the grid. So this is the best way to keep track of which parts are which. So as you can see, this is a 2 tile by 2 tile image. Now if I show you the tile set that I'm going to use for my demo program of Game Boy Color tiles, you'll see that these tiles and the font set here are arranged in such a fashion which makes it easy to draw the tiles out. So one thing to note as well are all of the colour palettes at the top here. So the Game Boy Color can have a maximum of 8 palettes for the background tiles. But one thing that is interesting is the colours are actually totally independent from the tiles. So although I've put the first colour to blue on them all here, which is the background colour, on the Game Boy Color the first tile, the first colour in the palette is always drawn still. So it's not actually the transparent colour. So in the first palette, the first colour will be the background colour of the whole screen. But in every other palette, you could have colour 0 be something totally different. But if you do have it different, then it will, the parts which we kind of expect to be transparent here will be whatever the first colour is. So what it also means as well is the palettes aren't really related to the tiles in any sort of meaningful way, which means that you can draw each tile with any of the palettes that you supply here. For example, the brick here uses palette 1, which is these colours here. But when you actually come to draw it later on, you could pass it in any old palette and it will look totally different with the varying colours that you use. So that is a good thing, and could be a bad thing as well. The good thing about it is you could dynamically change colours as the program's running, and it would also allow you to reuse graphics, just changing the palette to maybe make things a bit more interesting. So the way this is set up here, when you convert it, you'll be presented with the tile data and also the color palettes. So if you've been using my conversion program, then you would see the output data also provides you with the palette colors as well as the tile data. But up until now there hasn't been any way to really use those in any of the programs I've presented, so I will now open up our example program and get started. So this is the tiles here. This is the data for those images we just saw, and these are the color palettes here. So when you draw tiles on the Game Boy Color, you kind of have a tile map for the tiles in memory, but then you also have like another map which is for the tile attributes. So tile attributes are kind of like whatever color palette the tile uses, or whether it's flipped horizontally or vertically, or whether it appears in front of or behind of sprites. So some changes I've made to the tile drawing commands here is, in this demo here, to keep with the same sort of code which I've been using in the normal Game Boy, I've added an extra global variable just really for this example here. So to plot a tile, you first would set the attribute in this variable here, and then you would call to draw the tile as normal. But the code to actually draw the tile is slightly different. You see, when you draw a color tile, what you first need to do is use this command here. This swaps the video RAM bank, which is used for drawing the graphics. So first off, I'll set the video RAM bank to the attribute bank, and then we can set a tile at the position as if it was on the normal tile map and pass in the value of the tile attribute. You then have to make sure you switch back to the tile bank, and then you can plot the actual tile. So you're kind of doing two plots at the same location, just in a different video bank. Hopefully that will kind of make sense. And another new command that I've put in as well is to set the palette. So what you do is you pass the start palette ID, which can be a number between 0 and 7, and then the amount of palettes that you wish to copy into the palette area. And then also note that the data type for the palettes is different as well. All of the color palettes are 16-bit numbers, which represent the red, green and blue of the Game Boy colors. So to start off with, you set the tile data the same as before, and then afterwards you would set the palettes. So in this example here, I'm using all 8 color palettes. If I open that image again, and zoom in, you'll see that there's actually 8 palettes here. So although there are a maximum of 8 palettes, I believe in the converter program here you can put in however many sort of colors you like in here, and it will spit that out for you. Although be aware that you can only use 8 background palettes at any one time. So the GBDK command here, it pretty much mirrors what I've put there. You put in the starting palette number, then you pass it the number of palettes to copy, and then it expects the amount of data to be in groups of 4. So one palette is 4 groups of U16s, or 4 words, which is the assembly language name for a 16-bit number. So to draw a 16 by 16 tile, you kind of have to do the same thing over again, where you draw all 4 tiles and then you draw all 4 attributes using the attribute flag here, and then using the tile flag. So always make sure you keep what you're doing consistent. So if you draw the attributes first, then always make sure you switch back to tiles afterwards. So the attribute values, the first 7 values of the attribute 0 to 7 correspond to the 8 palettes. So if you pass a value of 0, then that counts as palette 1. So all this example does is it pretty much does a similar thing to the Game Boy example that I did, which uses an array, the actors array here, to hold load of positions, tile starting, facing direction, and these are the different variables that are expected in facing or movement type. So if I run this now, so what you'll see is all of these actors here are being drawn with different color palettes. So these are just the tile drawn actors as before, but this gives you a demonstration of the various ways to use color palettes. So all those colors which I actually set out in the image, notice that they look slightly different when they're actually running on the Game Boy itself. There is slight differences in how the colors actually appear, other than that, that's all I want to cover for this video. I'll go into using sprites and how to create some simple collision functions in my next video on the Game Boy Color. I'll obviously post a link to the code. Jump in and have a look and have a play around with the color palettes. Right, that's it for this video. I shall catch you next time.